What's in the box?
I bought the cheapest F136 engine on eBay, so I guess now we gotta go and put it in something. With many such cases, this was the result of throwing out a lowball offer during some late night eBay browsing, only to wake up and realize that I unexpectedly own a new project. For those not aware of what an F136 engine is, as was I shortly before coming into ownership, it was a co-development between Ferrari and Maserati to design a shared V8 platform that was both manufactured and assembled by Ferrari. It came in a multitude of configurations, with the main difference being those installed in actual Ferraris came with a flat plane crank, whereas the ones installed in Maseratis came with a cross-plane version. By the thumbnail, you can probably guess that we're going to use one sourced out of a Maserati, but we will continue to refer to it as a Ferrari engine because it was built in a Ferrari factory, and it will more than likely anger some people watching, and that is more than half the fun in building any of these projects. But if we stumble upon an equally good deal out of an engine from a Ferrari 458 or Ferrari California, then it will be a direct swap because they are externally identical to this example here. Having a new engine doesn't really do us much good unless we have something to put it in, and I put a few V8s into various BMWs in the past. So we'll continue the trend by choosing one of two potential platforms, the first of which being my E92 335i, which has served as a daily driver for the past 8 years or so, and despite having an N54 and its famed reliability issues, it has been a surprisingly solid car over that time. With the only performance modification to that car being an MHD Stage 1, the transition to an F136 engine will be a lateral move in terms of horsepower, but we will simplify the engine bay substantially, and we will swap out the possibility for wastegate actuator rattle with that of cam variator rattle. The E92 is, however, my fallback option, and growing up with 90s cars, I have an affinity for two-door hatchbacks as well as BMWs, so that leads us to the E81. It's sort of like a Mark 7 Golf and a 1 Series coupe had a few too many drinks one night, and this was the result. This is going to get us a chassis that's a few hundred pounds lighter, as well as a wheelbase that's a few inches shorter, which is going to make an equal amount of horsepower feel a little bit snappier. These things can be had for as little as $2,000 to $5,000, but the problem is that I am based in the United States and they were never sold in North America. We have this annoying 25-year threshold for the fairly unrestricted import of gray market vehicles, but our neighbors to the north in Canada have a more reasonable 15-year threshold for such vehicles as well. That means that there is a legal way to get this vehicle onto North American soil, and myself being just a couple hours from the Canadian border, so it's not unreasonable to set one up in storage and do the swap over the border until the car is finished. There could also be options of having the car registered in Canada, in which case it can reside in the United States for 3 months out of the year without any legal effects. So if anybody watching is or knows somebody who is a Canadian-based vehicle broker who deals with European cars, give me a shout with the email address in the description. It wouldn't be any fun to swap a stock engine into place, so we're going to be designing some induction parts as well as some exhaust parts to try to make a little bit more power, as well as see if we can improve upon the sound even further. By the thumbnail, you know that we're doing some individual throttle bodies, and one of the first tasks is going to be adapting 2 sets of BMW S1000RR throttle bodies to the cylinder heads. I chose these for a number of different reasons, the first of which being that these are dirt cheap. The second of which is that these are drive-by-wire throttle bodies, which means we don't have to worry about mechanically syncing 2 different shafts and having a complex throttle linkage. And as far as I'm concerned, there is no reason to build a car in 2025 with a cable throttle linkage. The final reason is that these should be sized just about perfectly, so let's use some round math. The S1000RR makes approximately 200 horsepower through a 1 liter at 14,000 RPM. That means that it should flow enough air for a 2 liter at 7,000 RPM. So if we have 2 sets of throttle bodies, it should make enough air to easily support 400 horsepower from a 4 liter at 7,000 RPM. And since our 4.2 liter makes a whopping 380 horsepower, these should be perfect. We're gonna send power to the rear diff through a ZF 8HP50 transmission. Yeah, I know, save the manuals, go cry about it in the comments, but the 8HP is one of the best modern transmissions you can get, and this one was dirt cheap at $430 delivered to my door. The 8HP50 has a lower torque rating than its big brother of the 8HP70, which is most commonly used in high horsepower turbo cars, but is going to be perfectly well suited to the normally aspirated 4.2 liter V8. I do intend to control that transmission with turbo lambic, which does offer the possibility of having a virtual clutch pedal. Yes, that means you will have a functioning clutch pedal to clutch kick this thing sideways while you're listening to your sweet Italian symphony. The plan is to design an adapter plate setup that will hopefully use nothing but cheap laser cut parts from our friends over at Sen so that we can adapt this to the F136 or any engine really with some very simple and affordable parts. With all that out of the way, let's go look at what was actually in the box. All right, so we've got our way oversized crate somewhat torn apart. Our intake manifold, which is extraordinarily heavy. It looks like we have a mostly uncut wiring harness. This will be useful to harvest any of the connectors when we eventually go through and make our own harness. One thing I didn't realize about these is that they are a dry sump, which is kind of cool. The motor itself arrived in pretty good condition. There are a couple scan markers on it from the previous owner. This was actually a failed project by somebody else. Hoping I might have a little bit more success. But if we look down inside the intake ports that I already uncovered, we're looking pretty clean in there. We are going to go through and do a compression test, but in the interim, let's take a quick look and see if this thing spins over. So that's promising. So it looks like the motor is not seized up, which is going to be pretty okay. For the $1,200 price tag, this was pretty complete. We've got the AC compressor and power steering pump, alternator, drive belts. Looks like the only sensors we're missing are really the coil packs. Got some random AC compressor lines and whatnot, so that'll probably be useful in adapting it to the car when we get there. Eventually, when we get to wiring this thing, it does look like they made it fairly convenient in accessing most of the critical sensors. It turns out this thing has some sort of accumulator for the variable valve timing. In reality, I didn't look too far into this motor at all, other than the fact that it was cheap, made some pretty good power, and sounds absolutely fantastic. So I think it'll just be a fun project to see where we end up with it, see what kind of power we can make with some induction improvements, as well as some header and exhaust improvements. I did a quick scan with the borescope and all the cylinders appeared to be in good condition, and while I lost the footage of cutting the oil filter apart, there was no forbidden glitter, and the oil itself was fresh and clean as well. If you've been around here for any length of time, then you know that the first step is to 3D scan the engine in which to design parts. Creality offered to send their Raptor Pro for me to try out, and while I generally have no interest in testing every single scanner that hits the market, I've never used one with laser, so I decided to give this one a shot. The main letdown, and I knew this going in, was the fact that it requires markers for the laser mode to work. I dislike using markers, and I generally try to avoid them whenever possible. If I have the option of just dusting the part with a scan spray and hitting go on the scanner, then that's the path I'm going to choose. As you can see here, it wants markers. A lot of markers. If you think you have enough markers, it probably needs some more markers. You can see in the software that despite all these markers, it did sporadically lose tracking, but to be fair, it did immediately pick back up where it left off. The Creality software is fairly intuitive and there's not a lot of settings to change. It was fairly easy to get a usable scan without much effort on the software side. It did produce a really nice scan with some crisp detail around the edges, which will translate very well into a mesh section sketch in Fusion 360 when we go to reverse engineer the bell housing. With the bell housing adequately scanned, it was time to get this thing onto the engine stand so we could scan the rest of the assembly. Here again, we need to spend a whole lot of time applying markers anywhere and everywhere that they will stick, and stick being the key word here. Being that this is a used grimy engine, adhesion is not the best, and a lot of them ended up on the floor after trying to stick them to various places on the block. With the amount of time investment needed to set up the Raptor Pro, I decided to take out my Vega and scan the engine while the point cloud was processing on the Creality software. Here with the Vega, I was able to capture all of the geometry of the engine before the Creality software was done processing the initial point cloud. I was almost able to get the full mesh out of the Vega before the point cloud was done processing, but I was still able to get a finished result out of the Vega before the Creality software had finished its mesh. You can see from the comparison of the scans that the Raptor Pro can put in better detail around the edges, which isn't surprising for a laser scanner, as long as you're willing to put in the upfront prep work. One thing you'll notice here, there are a lot of areas missing in the scan, and I attribute that to two different things. Number one is that something this size should probably be scanned in multiple sections and then merged afterward, thus adding to even more time to process the scan. The second is that the visual representation in the software, when you scan something a little bit larger, can make it a bit difficult to see which areas you've scanned more than others and which areas need a little bit more time to capture greater detail. That said, your success is really going to come down to the prep work that you put into it, as well as determining the best workflow for the object that you're trying to scan for this piece of hardware. I will definitely use the Raptor Pro again when it comes time to capture the bell housing flange on the 8HP50. In that particular use case, I think the upfront work is going to outweigh that on the back end of dealing with some less precise holes in Fusion. Speaking of Fusion, that's really going to be the main point of this side quest series, is to take a deeper dive on the CAD and make sure that I really try to capture every step of the process to show you what goes into designing some of these parts in 3D space. I'm going to do my best to fully capture the design process and then go step by step through the creation of each component. If that's the stuff that you're into, make sure that you subscribe so you don't miss any of those episodes, because they will be very sporadic throughout the time, as this is really just a filler side project to keep me busy when I'm waiting on parts for my main project, which is the 13B swapped BMW i8. So that's going to wrap it up for this episode. If you have anything else that you want to see designed for the F136, drop a line in the comments, or if you have any ideas on what might be cool on the exhaust side, I'd love to hear about those as well. As always, if you've made it this far, thanks for watching, and we'll see you next time.